All right, this is problem 7.5.47. We have a fax machine was bought for $600 and the fax machine depreciates at a rate of $20 a month. And we want to find a function that can be used to determine the values of the fax machine T months after purchase. And then we want to graph it. Okay, so they're actually giving us, for part A here, they're actually giving us all of the information that we need in order to write out the function, because if you're buying it at $600, that's actually your y-intercept, that's your starting point. And then the depreciation of $20 a month is actually a rate of change, which would be our slope. So if we were to use the variables that they're asking for here, this would be f of t, so that's function notation using t for the number of months, and this would be equal to negative 20t and then plus 600. And the way that I'm getting this is the 600 is where we're starting, and then we're decreasing by $20 a month. So that's where this negative is coming from, and that's because depreciation goes with a negative there for a slope. And then the t here is, since that's our number of months, so we can check this out here. We can think, well, okay, so, we're going to need a few points anyways to graph this. So let's do a few. So if we were to do f of 2, that would actually tell us at 2 months what the value of the fax machine was. And that's because this is t equals 2 would be 2 months. Okay, so when we plug that in, and we know that we're decreasing by $20 a month, and so we're looking then at 2 months, it's $560, worth $560. And I'll just do maybe a couple of other points because we're going to need a few points here in order to graph this. So let's just do f of 3. That would be negative 20 times 3 plus 600. So that is negative 60 plus 600, which is 540. Okay. And then obviously f of 0 here, where we're starting, when you plug 0 in, you're just going to get 600. So these are all ordered pair points. This is a 2 and a 560. This is 3 and 540. And this is 0 and 600. Okay. All right, so we have some points here. The second part of this problem did actually ask us to graph, so let's go ahead and do that. And one of the things that is important to think about with this problem, since this is an application problem and we are talking about buying a computer, when we go to look at our axes here, it does not make any sense for us to go into the negative territory because we are, whoops, this is going to be t and f of t for our axes here. Okay, I'll show you what I'm talking about. So I'm just going to do units of 100 here on this axis, and I'll do units of, go ahead and do units of just 1 on this axis. Maybe I want to do units other than that. I guess we'll just do units of 1. Okay. So the ordered pair points that we had, if we look at those, oh, you can see them. Okay. So we have 0 and 600. That's this point right up here. And then 2 and 560. It's going to be a little hard to see on my graph, but it's right there. It's going to have to be a little bit of an approximation. 3 and 540. So that's up here as well. Because my units are so big right here, maybe it would have been better to make this, but then the graph gets extended. But anyways, what I was trying to communicate here is that it doesn't make any sense for us to extend this line back here because that would actually be negative time. And it doesn't make any sense to have negative time in this context. The time 0 here where you bought the fax machine is the stopping point of the graph. Okay, so it would be negatively sloped looking like this and much easier to do with some grid paper than the way I'm doing it here. So that's it in this problem.